Okay, so this is going to be problem 2 of the exam, and I think the first thing I'm going to do is write out everything that is given to us in the problem. So we know that we have two wires that are connected together. Two wires that are connected together. So we also know that the force P at point A is what stretches the wires. So force P at point A stretches the wires. And we also know that point A moves horizontally 2.5 millimeters. So that's going to be pretty important. Okay, so we're trying to find the normal strain in each one of these wires. And so our equations we're going to use here. The sum of the forces of x, which is going to be this right here. And we're also going to need L minus L naught over L naught. And for assumptions, I'm going to write them out over here. We can assume that it's going to be static. It's going to be a steady state. And also isotropic. So even though I already have a kind of a diagram here, I'm going to draw another one out just because it helps me to visualize everything. So we know that the wire is 300 millimeters in length when force P is not acting upon it. And then, so that's what this line represents. And then this line right here is going to represent the length of the wire after P has acted upon it. So we know that, so even though we don't know this length, and that's what we're trying to figure out, we do know that point A moves 2.5 millimeters horizontally when the force P is acted upon it. So what we want to know is the length of the wire after it has moved 2.5 millimeters. And we're going to need the law of cosine in order to do this. So we're going to need c squared equals a squared plus b squared minus 2ab cosine c. And that's going to get the length of this wire once it's moved, or once force P is acted upon it. and then we should be able to use that to calculate the strength of the wire, which is what we're trying to find out. So, or the strain, I guess, is a better way to put it. So basically, we're gonna call this guy here L, just to match our equation a little bit better. So L is going to equal, we're going to do the square root, and since our initial value is 300 millimeters, well, we're going to do 300 millimeters, and then we're going to square it, and then we're going to add what we know for the point at which A moves is 2.5 millimeters squared. And then we're going to subtract 2, and then we're going to put AB back in, so 300 millimeters and 2.5 millimeters. And then it's going to be cosine. The reason that we're using cosine here is because this is not a right triangle, and then we're going to need, so we're going to need the degrees for this guy here, for lack of a better term. So we know that in between this top wire and this bottom wire is 60 degrees. Divide that by 2 is 30 for each side. So we know that if we extended this line here, this is going to be 30 degrees. That looks terrible, but you'll have to believe me. That's a 30. And then we're going to have on the opposite side 150 degrees. So, and then this guy right here is going to be 30 degrees as well. So we needed the 150 degrees in order to do this problem here. So we're going to stick this in the calculator, because I'm not smart enough to do that in my head. Okay, so I had my calculator set up wrong. It was in radians, so it should work now. Okay, take 20 here. So I keep doing it wrong, so I'm going to try to do it the right way on camera so I don't look like an idiot. So we're going to do the square root of 300 squared plus 2.5, I'll put that in parentheses, millimeters squared, and then we're going to do subtract 2 times 300 times 2.5, and then we're going to do the cosine of 150, and we should get the correct answer here. So it's going to be 302.16, we're just going to round up to 8 here, millimeters. Okay, so that's going to be what L is after A has moved back 2.5 millimeters. L should be 302 millimeters instead of 300 millimeters. So it is going to stretch a little bit. Okay, so we're going to try to find the strain here. So we're going to use L, and then we're going to subtract L naught, and then over, and we're going to divide all of that by L naught. So that's going to be what our value here is for L, which is going to be 302.168 millimeters. And then we're going to subtract our original value, which was 300 millimeters. And then we're going to divide the whole thing by 300 millimeters. And that should be the final answer there, if I've done everything correctly. Which I most likely have not, but we're going to try it anyway. 68, I'm going to subtract 300, and then divide it all by 300. Okay, so that should be 0.007, and then we're just going to do 4 decimal places, 2.